This lesson is going to explore and we're going to look at the different properties of equations that we'll be learning for this unit. So there are several more than the ones we're going to be doing today, but you'll only be responsible for knowing these. So let's get started. So the first one's one you're certainly familiar with. It is the commutative property. And the commutative property states that changing the order of your values does not change your answer. Now, it's important to note that the commutative property only works with addition and multiplication. If you were to try changing the order in an expression that had subtraction or division in it, you would actually change your answer. So the commutative property would not work there because you're actually changing a value. But an example of one that does work is, for example, a plus 6 is equal to 6 plus a. Here I've changed the order of a and 6 on this side, but the values are still equal, and you can try this with the number. You could put 2 in for a in both places and see that 2 plus 6 is 8, which is the same thing as 6 plus 2, 8 again. Here is an example with multiplication. We went from 5 times 3 times x to x times 3 times 5. We've changed the order of the multiplication, but we're still going to get 15x equals 15x. And you could even change it to 3 times x times 5 or 5 times x times 3. Any way that you change the order, you're still getting the same value on both sides. They're equal. So the commutative property allows us to rearrange expressions when we're solving to help us further simplify in our process. Here's one last one. Notice in this one that I have grouping symbols, but what I'm grouping together, the 9 times y, that part stays in the same order. So I haven't changed what's inside my parentheses. The order that has changed is this entire grouped expression starts first times x, and then on the other side it goes x times that whole expression. So here I changed the order of the big chunks being multiplied. That's one thing being multiplied by x. Here's your thing being multiplied by x. So that's what we changed the order of. Still commutative property. Okay. The associative property is when changing the grouping does not change the answer. So grouping symbols are things like parentheses or brackets. And so what this is saying is that with, again, only addition and multiplication, we can move around where those grouping symbols are, and we're not going to change the value. So here's an example. I have 6 times 4 grouped together times 5. That's going to be equal to 6 times 4 times 5. If you simplify both sides, you'll get the same value. Now, I don't want you to confuse this with commutative property. Commutative says the order can change and it won't change the value. Notice that the order stays the same in an associative problem. We go from 6 to 4 to 5. 6 to 4 to 5. So notice the numbers stay in the same order, but what changed was where my parentheses were. Because everything's multiplication, it works. Here's another example. Notice the order does not change. A to B to 3, A to B to 3. Because everything's addition, I can change where my parentheses are. Okay, the next property is the additive identity property. This states that adding 0 does not change an answer. So I think about this as your actual identity. If you add nothing to a number, you're not changing that number's identity. You're not changing what that number is. So with the additive identity, 3 plus 0 equals 3. So I added nothing to 3, so it stays 3. A plus 0 is A. All right, the multiplicative identity is where multiplying by 1 does not change an answer. So the identity problems, you'll notice you're always equaling a number you started with. So in a multiplicative identity, I'm still equaling the number I started with. But with multiplication, to not change its identity or its value, we would be multiplying by 1. So 6 times 1 keeps it still 6. I'm not changing the value of 6. Here, you can change up the order. It's the same thing. That's commutative property that lets us do that. But 1 times A still equals A. I haven't changed A's value. So the identities are always equal to the number you were starting out with. You do something to it, but it stays the same. So you multiply by the 1, it's still equal to itself. Additive inverse. This one states that adding the opposite number or term equals 0. So this is different than the additive identity where we were equaling the number we started with. With additive inverse, we're going to equal 0, but what you'll notice is that you'll have opposite signs. So here's an example. We have 2 plus negative 2. I've added the opposite of what I started with, and it equals 0. Here I have 3a plus negative 3a. I'm adding the opposite of 3a, and it equals 0. It can go in the opposite direction. Negative xy plus that's opposite is positive xy still equals 0. So with additive inverse, we equal 0. The multiplicative inverse property means we multiply a fraction or a number by its reciprocal, and that will equal 1. So notice your inverse properties are always going to be equal to a specific number. If it's additive inverse, we're always equal to 0. If it's multiplicative inverse, we're always going to equal 1. So here's an example. I start out with 7/8 and I multiply by 8/7. When you do this multiplication, top times top, 7 times 8 is 56. Bottom times bottom, 8 times 7 is 56. If you were to write that out, 56 divided by 56 simplifies to 1. Another example here is negative a divided by b times negative b divided by a equals 1 as well. Remember that these fractions are reciprocals of each other because we just flipped their order. So you might think, hey, these aren't reciprocals because the negative's in the same spot. It's not now in the denominator. What you should remember about fractions is it does not matter where you put that negative. So I could easily have written this one as b over negative a. It's the exact same thing. So this still is 1. These are reciprocals. So you can put negatives in the numerator, denominator, or out to the side. It does not change the fact that this fraction is a negative. So negative ab times its reciprocal equaled 1. So multiplicative inverse, we're always equaling 1. Okay, this next property is probably my favorite because it's the absolute easiest to remember. Multiplicative property of 0 means multiplying by a number or term by 0 equals 0. It really is what it says. 5 times 0 equals 0. AB times 0 equals 0. That's about it. Okay, and our last property is the distributive property, also referred to as distribution. So you definitely got practice with this property a lot last year in pre-algebra, so we'll quickly review it. So distribution is when we multiply or divide a term to a grouping that contains either addition or subtraction. Now this addition or subtraction has to be in between the terms in parentheses. So it looked like a number outside times, and we'll have either a plus or minus in the middle here and 2 values here. Okay, but if you are missing that plus or minus, you cannot distribute. Oftentimes, people will think they will need to distribute with an expression like this. Well, notice that this is AB, which is really A times B. You need a plus or a minus in between your terms in the parentheses to actually distribute. So let's look at an example. Here is an example, 8 times A plus B, where we are allowed to distribute. We have a plus sign in between the terms in the middle, in the parentheses. So because the terms in the parentheses are separated by addition, we are allowed to multiply the 8 times the A and the 8 times the B. And I love drawing these arrows to keep organized, giving us 8A plus, notice we keep that plus sign in the middle, 8b. We will often use distribution this year when we're solving equations because this helps break apart this multiplication and simplify our expression or our equation a little further. One more example is v times x times v times negative 9 gives us vx minus v9. And just so you know, we often use distribution when one of these terms or both of them are variables inside the parentheses. If you had something like v times 2 plus 3, you certainly can distribute. However, if you can simplify this, it's just 5, and that would tell you this was 5v. But you could also get that by doing 2v plus 3v, which are like terms that combine to 5v. So we like distribution because of times where one of these terms is a variable and we don't know its value. But always look for that plus or that minus in between your terms, and you keep that sign in your answer. Okay. So at this time, you've got some extra practice problems at the end of your guided notes right here on the screen. And I want you to pause this video and work through those problems. In a moment, when you're finished, then click play and we'll check them together. So pause now. Okay, so you have now practiced and completed these problems. So let's go through the properties that are represented here. So our first one is 5 plus a equals a plus 5. We had addition in both, and there's no grouping symbols, but the order did change. So that should be the commutative property. Our next one, we're multiplying something by 0. So it is the multiplicative property of 0. For C, we are actually not changing the order. Notice it's 3AB, 3AB. What's changing is where our grouping signs were located, meaning this is the associative property. Okay, D is a little bit trickier. Notice we have grouping symbols, so you might instantly think, oh, associative. I want you to break that habit of when you see parentheses, it's associative, because it may not always be, and this is an example of that. Here, notice that what's in the parentheses stays the same. I still have 6 plus 2 in the same grouping. I have 8 plus 1 in the same grouping. So I actually did not change my groupings. What changed was the order of those groupings. So here I started out with the 6 plus 2 and had the 8 plus 1 added after. Here we start with the 8 plus 1, end with 6 plus 2. So because order changed, it's commutative. E, we are adding 0 and not changing the identity. We're equal to x, so it's additive identity. F, we are adding and equaling 0, so it's additive inverse. We're adding inverse operations there. All right, G is distributive property. 2 times x minus 2 times 5a is 2x minus 10a. And H is the multiplicative inverse because we multiplied 2, which remember we can write, as 2 over 1. I don't know how to zoom out. There we go. 2 over 1 times 1/2 equals 1. So that's multiplicative inverse. Those are reciprocals. J, additive inverse. So with this one, you might not have initially thought additive inverse because you see addition here. However, remember, any subtraction can be written as plus a negative. So this really is adding two opposites. The next one, we keep our order the same, 7, 1b, 7, 1b, so it must be associative. The grouping changed. Here the order changes, but it's all multiplication, so that one's commutative. And lastly, that is the additive identity. 0 plus something is itself. And that concludes our properties lesson.